resistors in parallel. So here we get our power supply gets switch. We have two resistors in parallel, and we are going to use a method to measure the current that flow through our circuit. This is very different than what you've seen before, resistors in series, because if the current flow through our circuit, and suppose that the main current arrive at this point, we get branches here. So here the current gets choice. The current can pass through R1 or a current can pass through R2. So the current here is divided by 2. Largest resistors means small currents, and small resistors mean great current. The main current arrive at this point, and we get two branches. We have one branches of R1, and we get the second branches of R2. So the current gets a choice here. The current can go through the first resistor or through the second resistor. But note something very important is the potential drop, the potential difference at this point is the same, and we get our ammeter to measure the current that flow through our circuit. So what we have, so the important relation is that the total voltage of our circuit that we have here, so the total voltage of our circuit is equal to the voltage here, and it's the same that the voltage you have here. As two light bulbs are in parallel, the voltage you have here, the voltage of the power supply is the same of the voltage you have here. It is the same that the voltage you have here. So VT equal V1 equal V2. So from this, we've seen that the total current that I have here is divided by 2. IT, the total current equal I1 plus I2. So we can write VT over RT, that is IT, equal V1 over R1, that is I1, plus V2 over R2, that is I2. Okay, this relation is very important. We can cancel V, as we've seen before that the potential at the power supply is the same we get here, and it's the same also we have here. So we can cancel V, and then we have 1 over RT equal 1 over R1 plus 1 over R2. Very important. And if the resistors are in parallel, you can't add the resistors as we used to do it in series. You have this reciprocal addition. So it's 1 over RT equal R2 plus R1 over R1 times R2. This lesson must be given just after the reciprocal, the calculation of fraction and reciprocal inverse in mathematics, so it will be very easy for the kids to not get confusion when doing this or any difficulty when doing this kind of operation. They can really use mathematical tools to solve this kind of problem. So RT equal R1 times R2 over R2 plus R1. If you have R1 equal 400 and then R2 equal 350 ohms, we get RT equal 186.66 ohm. So calculation of the current that flow through our circuit, we get the total current is the total voltage divided by the total resistor. So we have 230 divided by 186.66 equal the current. So the current that flow through our circuit is 1.23 amps. As we get the voltage equal V1 equal R equal V2, we can equal R1 I1 equal R2 I2 I1. The current that flow to the first resistor, so the current that flow through this part equal V over R1 equal 230 divided by 400 equal 0.575 amps. So the current that flew through the first resistor is 0.575 amps. You can make the same calculation using RV and R2. But there is another way to find the current that flow through the second resistor, as the current that flow through the main circuit, the main Y, is divided by 2. This current, the main current minus I1 is I2. That's what I've done here. So I2 equal IT minus I1 equal 1.23 amps that you have here minus 0.575. That's the current that flow through I1. I get the current that flow through I2 equals 0.675 amps. So this is for 2 resistors in parallel. Now we got 3 resistors in parallel. So the same circuit gets our amps to ammeter to measure the current that flow through the main circuit, and then you get the first resistor, the second one, and then the third one. They are all the light bulb here. So now it's over to you to make the calculation as you have made it before, to calculate all the necessary parameters. So based on the previous calculation, 2 resistors in parallel, you have to calculate using your mathematics tools that you've seen with your mathematics teacher. You have to calculate the total resistance in our circuit, so the effective resistance, and then you calculate the main current that flow through our circuit, the current that flow through our through the circuit. Okay, this is the main current that flow through our circuit, this branch and then this branch. Know that if the currents arrive at this point, the main current that flow until this point is divided by 2. One pass here, the other pass here, and this one arrive at this point is divided by 2. One pass here and the other pass here. And so you calculate I1, the current that flow through the first electric bulb. You calculate I2, the current that flow through the second light bulb, and then I3, the current that flow through the third light bulb. I give you the resistor of R1, the first light bulb is 400 ohm, and the resistor of the second light bulb is 350 ohms, as the resistor of the third light bulb is 300 ohm. So it's over to you to make this calculation.